Hello, I welcome all of you in Chapter 5 Factorial Designs, book name Design and Analysis of Experiments by Montgomery. This is the fifth part of the video recorded lecture series. In this video, I will discuss about the example that has been given in the book. We will solve this example by hand. I will use the help, I'll take the help of the Minitab in this example. So let's start. An engineer is designing a battery for use in a device that will be subjected to some extreme conditions in the temperature. So we are interested in the temperature. This is the important thing we have. Then the only design parameter that has been taken, that he can select at this point is plate material. Means from which plate material he will manufacture the battery. And the one more important thing is the temperature. So he has three possible choices for the material type. So we will say that the material type has three levels. These are basically levels of material type. When the device is manufactured and shipped into the field, the engineer has no control over the temperature extremes, means the temperature of the battery at where the battery is working. So he known from the experience that the temperature will probably affect the battery life. So the temperature, he knows that the temperature significantly affects its battery life, but now he is interested in finding out the statistically the thing he's claiming. However, temperature can be controlled in product development laboratory, means under the pilot stage for the manufacturing of the battery in to perform the tests. So he decide to take all three plate materials at three temperature levels. So he take then he's taken 15, 70 and 125 as three levels of the temperature. So we have two factors now. One factor is plate material and the second factor is temperature. And he's now going to make a factorial design, and then he will analyze the experiment. So look at there. First of all, he took temperature material type A is equal to 3, means A is equal to 3, means the level of the material type are 3. B is temperature, and you will say that B is equal to 3, means the levels of temperature are 3. The levels are 15, 70 and 125, where material types are denoted by 1, 2 and 1, 2 and 3. This one. So I will now explain the data collected how. At the material type 1 at 15 degrees centigrade, he took 4 observations. So these 4 observations, if you have gone through my previous lecture, you know that these are my replications, and you will represent these replications at y 1 1 1 and this one y 1 1 2. Same is the case, we will represent these two also, and the last one will be y 1 1 4. So the first one means that at material type 1, the second one means at temperature level 115, and third one means that it is the first replication. Replication is performing the experiment at the same conditions. So my conditions are material type 1 and temperature 15 degrees centigrade. And then what is 114 means? This experiment, the observation or response of 180 has been calculated or observed at the inputs of material type 1, temperature level 1, and this is the fourth replication. Same is the case, you can see that all of the levels or all of the treatments, there are 4 replications has been taken. The more replication has been taken, the more our data will be, you can say, reliable for the testing, or it will be good because there will be less chances of the mistakes. So like this, all of the replications have been taken. So now I'm going to explain. A is represented by material type, B is the temperature. Both of them are quantitative variables. We have to find the effects of material type and temperature on the life of the battery. Is there a choice of material? We have to select a material among 1, 2, 3. Which one we should have to select that will prolong or that will increase the life of the battery regardless of the temperature. So there should be a robust product that, or robust product means that can work on low temperatures as well as on high temperature, and the temperature will not affect the life of the battery. Our objective is to choose such a material. So while solving this, what we will have to do, I have told you the formulas in the lecture 4, means in the video recording 4 of this series. So first of all, what we have to do, we have to take the sum of all of the this row sum. We will take now, like you can say that 539 plus 229 plus 230, like how I will let you know that it is 539 plus 229 and plus 230, and it will be equal to 998. Same is the case, you will take the sum of 623. 623 is this first one, okay, and then you will take the sum of 479 and then 198. If anyone haven't did it earlier, so he can for that, students, when we take the sum of these four values, we got 539. Same is the case, the sum of these four values will result in 229. So we have taken the sum of all the replications that have been performed at the same conditions, and then it is easy for us to take the summation of all these treatments. Then we will do the column wise sum. Column wise, like this: 539 plus 623 plus 576. So the sum of these three values will result in 1738. Same is the case, we will take the sum of these three values and it will result in 1291. The sum of these three, 230 plus 198 plus 342, it will result in 770. So like we will now, the row sum, it will tell us that the sum of square for the factor A, and the factor A we have, factor A is material. And now the second, you can say, and the second, the sum of all the columns, this, the sum of these values, 998, 1300, 1501, it will tell us the sum of square for the material or sum of square for the factor A. Then the sum of all the columns, these we can say, let me clear all the figure so that we can work on it easily. At the second stage, we will take the summation of 539, 623, 576. We got these summations for the columns, and then we will do take these values in order to calculate the sum of squares. We will get the sum of squares for the second factor, that is temperature, and we will say this is the sum of square for the temperature. In the next video, sum of square for the temperature has been calculated. So look at there, by taking 1738, 1291 and 770, we have used these three values in order to calculate our sum of squares for the temperature. So far we have calculated sum of square for our two factors. Now I will discuss about sum of square of totals, in sum of square of the whole problem. So as per the formula is yijk whole square. Yijk is the individual value. So we'll have to take the squares of all the values. It means 130 whole square, 155 whole square, okay, then 74, this third one value, whole square, till we will go through this last value in the table, that is 60. We will take the square of all the values minus 3799. 3799 is sum of all the values, means when we will take the summation of all these values, we will get 3799, 3799. This is the sum of all the values. And 36 is our you can say it is printed by in this formula as ABN, or you can say it is our capital N, means it is the count of all the values that has been taken in this experiment. So these are 36 values that has been taken in this experiment. So by using these formulas, you will calculate sum of square of the total, sum of square of material, sum of square total for the temperature. Now we will calculate sum of square of the interaction of the Sum of square of interaction means that we will have to calculate the sum of square for the interaction of material and temperature. But here the formula will be, please take into your mind that sum of square for the subtotal. In case of factorial designs, we will have to calculate initially the sum of square of the subtotals, and this sum of square subtotal will be equal to sum of square of the A plus sum of square of B plus sum of square of AB. And now we have sum of square of A for the temperature, sum of square for the sum of square for A for the material, sum of square B for the temperature. And now by using this formula, this is the formula for calculating sum of square subtotals. So use this formula in order to calculate this, and then subtract. When we subtract sum of square A, sum of square of B, we will get the sum of square of the interaction terms. So in order to calculate the sum of square of subtotals, we will have to take the sum of the interaction terms, all sum of all the interaction terms, means 539, 229. This 539, 229 has been taken or obtained from taking the sum of all these replications at a specific treatment. So you will have to take the sum of all the treatments. You can see that it is 539 whole square, the sum of first treatment. 2 to 9 is the sum of second treatment. Same is the case, we will take the sum of all of the treatments, all of the replications, and then we have gone through 342. Means in this dot 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 we have a total of 9 values in this whole sequence. Then 3799 again is the sum of all of the values, 3799, and 36 is the number of total observation that has been considered in this study. So in this way we will calculate the sum of square of the interaction. Now sum of square of the errors, the SST formula, sum of square total formula is equal to sum of square of A means material, sum of square of the B means temperature, sum of square of AB, and this is the interaction term, okay, plus sum of square of the error. In order to calculate the sum of square of the error, we will took SSA, SSB and SSAB on the left hand side of equality sign, and we will now calculate sum of square of the error, because these four values we have calculated using the formula, and we got sum of square of the error equal to 18,230.75. Keep in mind that all of these formulas have been explained in the previous fourth video of this lecture. Again, a short snipes for the calculation of SST, SS material, SS temperature and SS interaction has been provided in this slide. You can take help from them. Then we will make the ANOVA table. In this ANOVA table we have the sum of, first column is sum of squares. These sum of squares have been calculated for all these one, and based upon these sum of square values we will calculate the mean squares, okay, MS. But in order to calculate the mean square we need a degrees of freedom. So we know that A is equal to 3 means the level of material were 3, so subtracting 1 from 3 is equal to 2. Again we have B is equal to 3, we have 3 temperature levels, subtracting 1 we got 2. Interaction terms, so interaction term what we will do, the formula is A minus 1 into B minus 1. So A minus 1, B minus 1, 2 multiplied by 2, it will become 4, and the rest of all of the values will contributed in the calculation of the error term. So 27 terms will be used in the calculation of the error. It's a very good model because too many terms have been contributed in the calculation of the error. This error does not mean that there is any mistake in the model. Rather than this error contributes in the variance calculation, means MS error. This MS error is equal to the variance of this whole model, and we will use this variance in the calculation of all of the mean sum of squares, and mean sum of square then contributed to the calculation of F naught and then P value. So when we will divide a sum of square upon its degree of freedom, means when we will divide 10,683 by 2, we will get 5,341. So this is our mean sum of squares for material type. Again, dividing 39,118 by 2, we will get 19,559. So same is the case, we will calculate all mean squares. Then how we will calculate the f naught? I have also told in the previous video that f naught will be calculated by dividing the respective mean square. Means if we want to calculate the f naught value for material, so we will divide the mean square for the material by mean square of the error, and we will get this f naught value 7.91. Same is the case if we want to calculate the f naught value for temperature, so we will use ms temperature divided by ms error. So this is our second f naught value, that is 28.97. The interaction the f naught value for the interaction will be taken as f naught is equal to mean square of int. Int means interaction for A's, and we will divide ms error. So we will get 3.56. So now there are two ways that how you can compute your you can say the hypothesis you have taken in the start. So I am going to the F distribution tables that has been provided in your book in the appendix, and we will compare the F naught value with the F distribution value. So there will be few different F distribution values have been taken. Let me write here for your understanding that the first value for the material type and the temperature, we will compare F naught with F of alpha a minus 1 and n, you can say the error term. So error term in this case we have, it is equal to a b n minus 1. So a 3 b 3 and n are 4. So n minus 1, 4 minus 1 is equal to 3, 3 3s are 9, 9 3s are 27. So we will write here alpha we have taken in this study as 0.05 comma a minus 1 become 2 and this value become 27. So we will compare this f naught value with this distribution value. Same is the case in for the material. I'm going to write here this value. For the material we will say f 0.05 b, okay, then a b n minus 1. In place of 0.05 you can also write alpha, and alpha is equal to 0.05 b minus 1, sorry here. So b minus 1 become 2 and again 27. So for the material and for the temperature we will use these two values in order to check that whether we have rejected our null hypothesis or we fail to reject or we have or we fail to reject the null hypothesis. Then we come towards f naught value for the interaction term. As in the interaction terms we have 4 degrees of freedom in the numerator, okay. So the generic formula I'm going to write for you people, yeah, and you can use this formula at any case. The generic formula is f of alpha comma v1 comma v2, where v1 is the degrees of freedom for the numerator and v2 is the degree of freedom for the denominator. So how we will write using this generic formula, this it will become 0.05 for the interaction term. I am calculating the numerator degrees of freedom for the interaction are 4 comma the numerator degree of freedom, we will always use error term in the denominator, so the denominator degrees of freedom are 27. So we will write here 27. So f of 0.054 comma 27, this value will be used to check whether our interaction has been significant or not. I am going towards the table and we will have to check these three values. Keep in mind that these are the over values that will tell us that whether our factors and their interaction is significant or not. So you can see in the appendix of the book that table 4 is the percentage point of F distribution. Unfortunately we have this table but it is in landscape mode in the book, so please open your books while watching these videos. We have written here, the first thing you will have to check that whether it is what's written. So it is f 0.05. This table is recording for significance level 0.05. Then you will check what's written at there. v1 it represents the horizontal row, whereas v2 the degree of freedom for the denominator it will represent it as a vertical row. So we will have to check the intersection of 2 in the numerator and 27 in the numerator, and we will get here 3.35. Let me go to the presentation. 3.3. So the 2 at 27 it will tell us that it is 3.35 and I will write the same value here as 3.35. Then we will check 427. So 4 degrees of freedom in the numerator and 27 degrees of freedom in the denominator. If I am not wrong, it is 2.73. So it is equal to 2.73. Now you will have to make your decisions, and you will make your decisions how? You will make your decisions like if you say that if our f naught value is greater than f of alpha v1 v2, then we will reject the null hypothesis. I hope people are so much aware from this course that you can make a null hypothesis. If not, so I'm explaining null and alternate hypothesis in a minute. So over your first null hypothesis will be h naught 1. Okay, so I'm writing here regard with the material that your first h naught regarding the material, it means that all of the material types have same effect on the battery life. Your and its alternate hypothesis will be at least one of the material type have different effect on the battery type. Your second null hypothesis for the material will be h naught represents not a 0, it's not. Okay, h2 naught. Your second null hypothesis will be there is no effect of temperature on the battery life, or your null hypothesis can be that the mean value for temperature level 1 is equal to mean value for temperature level 2 is equal to mean value for temperature level 3. Alternatively, you can also say that all of the temperature levels have same effect on the battery life. So this will be your third null hypothesis. You can take any one of the statement as easy for you. And the alternate hypothesis will be same as the case. You will represent it by H2A. Okay. So your alternate hypothesis will be the temperature levels have different effect on the battery life, or at least one of the temperature level have significantly different effect on battery life. So like this you can make your alternate and null hypothesis. And the third null hypothesis for the interaction will be the null hypothesis for the interaction be there is no effect of interaction on the battery life, and the alternative hypothesis can be there is a significant effect of interaction terms on the battery life. So like this you can make your null and alternate hypothesis. In the video 4 I have explained in detail that how you will formulate your hypothesis. So these hypotheses have a very importance in your research work, or you can say in your exam, because you will have to write the hypothesis first in your questions. Okay, so then now we have calculated all of the values, we know the criteria, so we are going to compare this criteria for the first one, material. So the material value we have 7.91. So 7.91, it is whether greater or not than 3.35. Yes, it is greater. So we say that we reject as over f naught value is greater than f distribution value. So we reject the null hypothesis. Okay, and it is found that there is a significant effect of material types on the battery life. Then we will again use the same for temperature. So f naught value for the temperature is 28.97. You can look from the table. So we will write that 28.97 is greater than 3.35. Again you will write we reject the null hypothesis as our f naught value is greater than the f distribution value 3.35, and it is found that there is a significant different effects of temperature levels on the battery life. And the third one we will use for in the interaction terms. So for the interaction term we have 3.56. So 3.56, that's the mean sum of square for the interaction, and it is greater than 2.73. We have taken this value from the table. We write it 2.73. So you will say that we reject the null hypothesis, and it is found that there is a significant of interaction of material type and temperature on the battery life. So in this way we will compute and we will explain over ANOVA table. Now we will move towards that we can also make these main effect plots by using the Minitab. So let me, I'm going towards the Minitab and I will formulate the first of all full factorial design for you people, and then I will conduct the analysis in the Minitab. So open the Minitab, go to stats, then DOE means design of experiment, then factorial designs. Click on create factorial design. You will have two factors in this study, and each of the factor has 3 levels. So there is no such option of 3 levels. Then click on general full factorial design. Then click on display available designs. So it said that general factorial design can have from 2 to 15 factors. Then click on designs. You'll have to select the first number of levels. So number of level for the first factor are 3. Number of level for the second factor are 3. There are 4 replicates. This is the most important. 4 replicates at each treatment. We'll say click OK. Factor. Now the first factor name is material. So I will write material. The second factor is temperature, and there are 3 levels. Okay, so it is there are 2 options for you, either to write 1 2 3, or you can write the exact values. So for the material I have 1 2 3, whereas for the temperature I have the values. You can see, let me check in the previous slide, the values have been provided there in the slide. So values were 15, 75 and 125. Click OK. Then you will have to click on the options. Always uncheck this one, randomize run, because if you click on this randomize run, it will be very difficult for you to input the whole data. Then store the design in the worksheet, means the design will be stored in this sheet. Click uncheck randomize runs, click OK. Then results, so I will need the summary table. Okay, fine. So like this, just click OK. So I got these 2 values, my main factor combinations factor data, and I will have to input a data in front of them as per the design. So I will write here battery life. So it is, you will take these 2 values, 115, then again it will be like here somewhere 115. Yeah, the second value 115. So based upon this table, I will have to input the data. Let me tell you that how I will put the data. The first value is material type 1 and the temperature 15. We got the battery life equal to 130. So I will write here 130. Then I will check here material type 1 and temperature 75. So material type 1 and material, okay, temperature is 70, so I will write there by mistake 75. It's a typo mistake. You will assume this 75 here as 70. I can't change it manually because the values, the design has been made by the software itself. So I will write 34. That is a combination of material type 1 and temperature 70. So 34. Same is the case. Now we will use material type 1 and 125. So material type 1 and temperature 125. The first value is 20. Same is the case. I will use the same scenario for entering all of the value. Let me enter this last one for you. Then I will enter the rest of one for myself in order to save the video time, as the video is getting too much longer. So 2 and 15 will be equal to 2 and 15 is equal to 150. So I will write in Minitab 150. I am entering the rest of all of the values and resume the video then. I have input whole data. Then I will go to stat, DOE, factorial, analyze factorial designs, the responses. So I will click on this battery life C7 and then I will click on select. So my responses have been selected as battery life. Then I will click on the terms. So it's okay. My analysis system will be on material, temperature and their interaction. Covariates as it is, it's okay. Options, no need to change anything. If you want to change your alpha value, you can change your alpha value from here. Confidence interval for all intervals. and then stepwise it's all okay. Graphs, so I need okay, display only model terms, you can say, and display all terms. I need display all terms. Then individual plots, or you can say 4 and 1. Okay. Results, I need all these results. You can say also expanded tables. These are quite better than another one. Storage, nothing I need. Click OK. So in a meanwhile you will get the whole table. So this table is similar variance, and you can see that we have calculated our f naught value equal to 7.91 for the material, 28.97 for the temperature, and 3.56 for interaction. So look at there. So in this slide, look at this: 7.91, 28.97, 3.56, p-value 0.002. We cannot calculate these p-values manually, so we will use softwares for calculating. You can see that 0.002, 0.00, and 0.019. These are the p-values calculated. So all of the calculations we have performed using manually, we can also confirm them by using the Minitab. So the question arises that we have left this notes for the calculation of these main effect plots. Minitab, go to interaction terms, stat, ANOVA, and interaction plots. In the response, select battery life. In the factors, select material and temperature. Click OK, and look at this. This is the same graph as you have seen in the book. So in this way we have calculated the one. Now we will interpret these graphs, that what these graphs are saying to us. So by interpreting, you will see that the battery life is on the y-axis, and we got the maximum battery life at temperature 15 degree Fahrenheit for the material type. You can see this material type 2. Yeah, this material type 2 has the highest battery life at the lowest temperature. However, you know that from the question statement that either the most of the cases that battery works at the higher temperatures, so we will have to select such a material that is robust for working at higher temperatures. So at higher temperature, you see that the material type 3 has the best performance as compared to material type 1 and 2 at 125 degrees centigrade. Same is the case, material type 3 has again best performance as compared to material type 2 and 1 at 70 Fahrenheit. So we will prefer material type 3 for our use in the battery because it has good results as compared to material type 2 and material type 1. To check the normality of the data, we have plotted normal probability plot for residuals. As an example, 5.1. The same plot has been formed in the Minitab. So look at this normal probability plot, and you can see that this graph is almost resembles to the one that has been drawn in the book. Again, you can compare it. Okay, and now the second one graph in the book is residuals. So I'm now going to plot this one. The second plot we have obtained is residuals versus fitted values. So you can see all of this graph and this one that has been provided in the book, they are almost same. In the book they have taken on the x-axis 50, 100 and 150, whereas in the software has taken 50, 75, 100, 125, 150 more ranges. So the values are quite at distance to each other. Then histogram tells us that our data is almost normally distributed, versus it says that all of the values follow the random order because there is no set of 7 values going above and no 7 values going down. There is no trend, no cycles. So all of data is found to be normal and data qualifies for the further testing. The Pareto chart has been made in order to determine which of the factor or interaction has the greatest effect. So you can see that the term B, temperature, has the greatest effect on the response. Okay, then A has little bit some you can say less response as compared to the temperature. Material has, and then interaction has the least effect as compared to temperature and material. You can also verify these graphs using sum of square values. The sum of square value for the temperature is the highest, 39,119. Material has less value 10,684, and interaction has the least value as compared to above two 9,614. So ANOVA table assumes that or treats that all of the levels are quantitative, but in this case we have temperature as quantitative while material type as qualitative. So we will use the regression analysis, or we will develop the regression models in order to find the effect of input variables like material and temperature on the output or dependent, which is our response, that is battery life. So in short, we want to regress the effect of temperature and material type on the battery life. So we will do the regression analysis now. In the regression analysis, A represents linear effect of temperature. When our variable have the power of 1, it will be a linear effect. Okay, when a variable has a power of square, that is, we will say that it's a quadratic effect, and then cubic effect A cube. So mostly we neglect the cubic effects and above. We will only go towards the squared effect only. So A, it represents linear effect of temperature. B shows linear effect of material. A square, it shows the quadratic effect of temperature. AB shows the interaction effect of temperature. To the ANOVA stat, go to stat, regression, then regression, fit regression model. Select response as battery life. Continuous predictors are material and temperature. Select OK. In a while you will get the values. These are the values for your coefficients. Material means if you make a regression analysis equation, you will get the equation like this: 115.9 plus 20.96 material minus 0.730 as temperature. So you see that material has a positive effect on the response variable, that is battery life, and whereas temperature has a negative effect, means with the increase in the temperature the battery life reduces. And then this positive value of the material says that the material type 2 and 3 has higher good values as compared to material type 1. So this is the analysis of variance plot, that material has a significant value, temperature has also a significant value, and we will get the regression equation like this in the general full factorial design. So this is our regression analysis equation. Let me maximize the screen so you can see it in a better way. So battery life will be equal to 105.53 minus 22.36 material type 1. So material type 1 has a negative effect on the battery life. Material type 2 has a positive effect on battery life. Material 3 has also a positive effect, means it is plus 19.56. Same is the case. The each and every coefficient that has been associated with the material levels, temperature levels, and the interaction of material and temperature levels, all of these a detailed regression equation has been provided in the general full factorial designs. So that was all about the regression analysis equation. In the last two slides of this lecture, that if we have more than two factors, what we will do, the sum of square of total will be equal to sum of square of A, sum of square of B, sum of square of C, plus sum of square of AB, sum of square of AC, plus sum of square of BC, then sum of square of ABC. So like this, it moves and it goes on if we have more factors. And then the last slide, if what will be now the what table for three factors, so we will get main effect for factor A, for factor B, factor C, then AB, AC, BC, and ABC. So that was all about this chapter. Thanks for watching this whole lengthy series for the chapter 5 full factorial designs. If you are new to my channel, please subscribe my channel. Thanks for watching this video.